All right, so hi everybody, welcome back. Solving nonlinear inequalities. Now, I will make the assumption that we're working just with one variable here. Solving nonlinear inequalities is actually quite a pain, and you do have to be kind of comfortable in possibly utilizing graphing tools or other tools to be able to even get some intuition behind it. Now, when you're solving linear inequalities, which I've done a video on, and I'm going to make the assumption that you understand how to solve those. I'll put a link up above there if you want to kind of go over that. And when you're solving those linear inequalities, we saw that when you have these inequalities, so for instance, you have these ones that we're kind of working on. The key thing with the linear ones, and really the only problem in solving linear inequalities, was the fact that if we were multiplying or dividing by a negative number, right? And if we were multiplying or dividing by a negative number, then the only thing that happened was the inequality just kind of swapped, right? So you would run into this whenever you had to divide or multiply by a negative number, which pretty much was the only headache we ran into. And that's why people love working with linear inequalities or equalities, because they're just lines and it's so much nicer to deal with it. Unfortunately, with nonlinear inequalities, although you can run into these problems where your inequality switches side, but there's actually a little bit more because of the fact that the left-hand side and then the right-hand side of the inequality could possibly be nonlinear. So let's kind of do a little bit of a setup first. So here's my left-hand side, and then here is my inequality, so whatever that inequality might be, and here is my right-hand side. So it can be anything, but I'm going to make the assumption in this particular video that either the left-hand side or the right-hand side, at least one of them or both, is basically a nonlinear expression, okay? And again, so that comes down to being comfortable in distinguishing between nonlinear and then linear expressions. So I'll put up a link up above there for you, just in case, because this is kind of a continuation of a video. And so if we have a nonlinear expression on the left or on the right-hand side, you will quickly see that you're going to run into some major problems, right? Rather quickly, if you wanted to be able to solve the inequality just by hand without using any other methods. Some of them you are going to be able to solve and you can probably step yourself through, but even with simpler ones, sometimes it's a headache, okay? So let me show you a few examples of these so that you don't think that it's just magical where we're just flipping an inequality and then we're just dealing with multiplication or division by a number which is negative. There's a lot more that can happen, okay? So things to keep in mind, right? If you're dealing with nonlinear expressions, you might have exponents which are raised to a higher power. You might have, okay, for instance, radicals that you're going to be dealing with, which are, for example, exponents that are maybe fractional. You're going to have your variable in the denominator, and all of these things are going to give us quite a lot of headaches, okay? So if we take our first example here, so we have x cubed, and then we want to try to find when that is less than or equal to x plus 2. So let's just kind of hone in on this example just on its own. And if we tried, so let me copy this, and if we tried to do exactly what we did with the linear ones, well, what we did was we tried to simplify them as much as possible. Well, here, there's nothing to simplify. It's just x cubed on the left. There's no like terms to correct. It's pretty as simple as it gets, x cubed. And then on the right-hand side, it's x plus 2, which is actually linear. It's an expression which is linear. It's kind of a line. So once we have this, how would you try to approach this? I mean, I guess you can say, okay, well, let me try. I would have x cubed. I'm going to move these terms over on this other side. And I'm going to get minus x and then minus 2. And then all of this is going to be now less than 0. Now, because we're just moving terms around, it's not going to change the inequality. And I talked about that. Again, you can go back to the original link that I provided for you. So moving a term is not really a big deal. But that doesn't help us that much in this particular expression on the left. Because now, like, what do we have? Well, we have to deal with this, which is a polynomial, and it's order 3. And we want to know when this polynomial is basically less than or equal to 0. Right? That's what we want to know. And sure, we can think of it as polynomials, and we can try to solve this. You know, we can try to figure out and solve, plug and play. But because it's cubed, that's not that easy, right? So dealing with these inequalities that are nonlinear are going to give you some headaches. So I want to try to show you, how to at least get some intuition into it. And what I try to do with these, now of course, if you're in a class and nobody allows you to use any tools, then it's going to be very hard. But some tools, kind of visual tools that you can think of, is think of the left-hand side as basically just some kind of a function, and then the right-hand side is also a function. And then what you're doing is you're trying to find, okay, when one function is, in this case, less than or equal to the other one. So I'm going to remove all of this, and instead of trying to be brave and solve all of these on my own, what I'm going to do is I'm going to show you that, think of it this way. Think of this x cubed just on its own, and think of it as a function, all right? So let's say I have my left-hand side, I'm going to call this, okay, f of x, and I'll put a subscript L because it's on the left-hand side. And then what I'm going to do is I'm going to have my right-hand side, so right here, and then I'm going to call this f of r, okay? And so what I'm trying to do is I'm trying to find when one function, the one on the left, is basically smaller or equal to the one on the right. And if I do that, now this one is rather simple to graph because we're used to graphing x plus 2. It's just a line, right? As a slope of 1, it intersects the y-intercept at 2. If we were graphing it in the axes, the x cubed might be a little bit harder, but again, it's not really that super difficult for us because it is just x cubed. We could even use a table of values and then, kind of just fit it through. Now, because we have these wonderful tools of Desmos, I'm going to try to show you, how you can utilize them in dealing with these nonlinear inequalities because it's not that easy, all right? So what I like to do, okay, is I basically like to just kind of plot. So here's my plot, and this would be the plot of the x cubed, which is the left-hand side. And then, so on the right-hand side, I just have a line, which is x plus 2. And notice, so right here, so what I have is two different functions. And what I'm trying to find is, I'm trying to find when, okay, so this function x cubed is basically less than or equal to the x plus 2. Now visually I can see that, right? So I'm going to kind of take a snap picture of this. Let me blow this up right here. Okay, so let's take a picture of that. And now, okay, so I'm gonna kind of do this. All right, and let me import it into our kind of work area right here. So I'm gonna put this one in here. Let's do that, and thank you, Desmos. I greatly appreciate, that we can work with these. Let me make this so that it's a little bit bigger here. So what we're trying to find is we're basically saying that, okay, well, we know that there is some intersection point, which I guess we could possibly find, right? Our intersection point is going to be somewhere over there, around 1.5. And if I go back to Desmos, I can actually probably kind of find it. So it's a little bbit, I guess it's 1.521 and possibly maybe more. All right. So whatever that value is, what I'm trying to do now is I'm trying to say, okay, so for which values of x, okay, is this function right here going to be smaller, okay, than the blue line? And clearly, so what it's going to be is, so if I look at this, it's going to be for some x, okay, and it's going to be less than or equal to, and now this, unfortunately we're approximating this, so it was 1.5 and so on. I'm going to put dot, dot, dot. But that's why I'm telling you that this is a hard problem to try to see. So for these values of x, which are smaller than that 1.5, whatever it might be, this x cubed is going to be smaller than the x plus 2. And I can see that directly, right from here. So if I keep blowing this up, I mean, this is what happens, right? So the x cubed just kind of explodes downwards, and then the linear line, which is just a line, is just going to go nicely linearly to the left. And now you might say, well, okay, I mean, that's nice, but so I can find it, and I can use this tool, and I can find what this intersecting point is, and then I can find the values for when this inequality holds. Would I be able to do that without actual graphing tool or some other tool? And I will tell you that unfortunately at some instances you may not. Now in this case, once you learn the functions like x cubed and x plus 2, you can kind of sketch and figure this out. Once you get a little bit of functions under your belt, which is kind of the grade 11 content which most students study. So some of them you may be, but unfortunately other ones it's kind of hard. And the point of this video is to show you that inequalities which are nonlinear do not follow just a standard procedure, okay? Because a lot of them might be different, all right? So that was one example of an inequality that we kind of solved through graphically. So here's another one, which is actually, maybe you would think, a little bit easier, all right, than the one that we just did. So what if I had this? So I have my x squared, and I'm trying to find when this is greater than 1. And now, if you're solving this, you might say, oh, well, this isn't that bad to solve, because what I'm going to do is I'm going to say, let me take the square root of both sides. And what I'm going to get is this. Now, of course, it's going to be plus or minus, right? And you might say, okay, well, I've solved this, right? I have x, okay, is going to be greater than the square root of 1, which is just really 1, right? We can find what that is, and it's going to be either positive or negative. And this might lead you to the wrong path. Now, let's think about that, okay? Let's think about, again, what this means, and in terms of if you're taking these just in general, and so here, so this is a quadratic, right? This 1 is basically just a flat line, okay, at 1. So it's kind of linear, right, in the sense where the slope is 0. So I'm not going to draw this. I'm going to put it into decimals in just a moment. But I just want to see you, show you how, this type of thinking of just being able to solve something like this, okay, can take you on the wrong track, all right here. So x squared, really x squared is just a parabola, okay, so it goes and opens upwards, all right? So that's what we have within here. And now, if I complete this, so I'm going to have, say, so this goes basically through my line of symmetry is directly attached. Okay, let me go through here. Okay, so to the parabola, let me just make it straight there. So there you go. So this is my x squared, right? That's on the left-hand side. Now, on my right-hand side, I basically just have 1. Now, what is 1? If you plot 1, so let's say this is 1 right there, right? Let's say this is 2, this is 3, and so on. Okay, so what you would have is you would have a flat line going through 1 like this. All right, so we would have that. And now, notice, if you think about this, so you have x squared is supposed to be bigger than 1. Where is x squared bigger than that 1? Well, okay, right here it's bigger, and right here it's bigger. And so from here, so from our answer, we can see that, oh, okay, I guess the intersecting point, right, the x squared equals to 1. So these points right here, we could have found, right? So this would have been at 1 at -1. But notice that x squared is actually bigger for x, which is less than -1. Okay, it's moving in this direction, all right? And it is, so moving in this direction, it is for x which is greater than 1. But if we took the square root right here, notice that this sign in one of the signs, so here it's changed, and here, right here, it's kind of stayed the same for that. Now, why might that be the case? Well, the reason is negatives, right? So for values of -x, okay, that inequality unfortunately might flip on you. But it's not always that easy to see. But graphically, we are able to see that, okay, pretty quickly. So I always, again, whenever you have an inequality and you have on the left or on the right, one thing is a nonlinear expression, which you can think of it maybe as a function. Think of it, okay, try to graph them out and then get the intuition behind it and then see what is happening. So if I graph this on decimals back, if I go back in here, let me remove these, right? And if I plotted my x squared, and then if I plotted my, this was, I guess, I forget, just 1. Okay, so this was just, I'm going to put it as y is equal to 1. Okay, so we basically have something like that, right, which we drew. And these are your points there of the intersection. And now if I plotted, okay, and this is again something which is super useful, okay, in decimals. If I do this, notice that it highlights for you the regions for which values of x, okay, are going to work here. And notice that it's to the right of the 1 and then to the left of the -1. The dashed lines means that it can't count 1 because we have greater than, so x squared is greater than 1, right? It doesn't equal to it. So decimals actually provides you these tools so that you can see. And just solving them blindly, okay, if you would get in here, you might get the wrong idea. And that's the problem with nonlinear. Unfortunately, okay, it doesn't follow direct, straight rules that you have. You have to treat kind of the values of x which are positive and negative kind of maybe differently than you normally would. So here's another example that I want to show you. So I want to show you a few examples and you can go through as many as you like here. So let me show you this one. Okay, so I'm going to copy that and I'm going to paste it in here. So for this example, so notice we have a square root on the left and then x plus 0.5 on the right, which again is just a line. So these aren't really that super complicated, but okay, they do play a role. So again, if you try to solve this inequality, what might you try to do? What you might try to do, you might say that, okay, well, I guess this is the square root, and you might think, what if I square it? So maybe I can square it. So if I square it, I'm just going to get x, and that means I'm going to square both sides. So this is going to be x plus 0.5 squared. All right? And you might get something like this. And now, of course, you can expand this out. So you can expand it out for yourself. So it's going to give you, so if you would expand this out, you're going to get x squared, all right? And then it's going to be plus x and then plus 0.5 squared, all right? So I just expanded that out within here, okay? And we're going to get that. And now you might say, okay, well, let me move this over on the other side, and I'm going to get 0, okay? So since I'm moving, okay, maybe I won't change the inequality. And then I'm going to get x squared plus x plus 0.5 squared minus x. So that means these two cancel. And what I have now is I have x squared. That 0.5 squared, I'm going to just put it as 0.25, 0. right? And you might continue. So you say, all right, great, let me move this over. This is going to be 0.25, but now it's negative, okay, in this case, and this is going to be that, okay, x squared. And now you're going to try to take the square root, but the square root of a negative doesn't really exist, right? So it doesn't really work. So you might again now ponder and might say, oh boy, I don't know, is there just nothing? Does nothing work? Okay, in this particular case. And now again, so instead of trying, I mean, you can certainly try to manipulate the inequality. But what I suggest is always, again, so maybe just go back and think, okay, what is really am I trying to do? What I'm trying to say is, when is the square root of x greater or equal to this x plus 0.5? That's what I'm really trying to do in this particular case. And now the square root of x, we kind of know what that looks like, right? If you've studied functions, okay? Maybe I will put up a link. So here you go. I'll put up a link to like kind of parent, some parent functions, okay? Kind of like the x squared and then the square root of x, okay? And then some other ones. So you can take a peek if you've forgotten. So now this again, so this one on the right is basically a line. So now I'm going to, let's say, plot it into decimals, okay, within here. So I'm going to put it in. Let me remove this. And I have one of them, which is just square root of x. And then the other one, which was x, I guess, plus 0.5. All right. So this is kind of what I had. And so within here, so if I go back in here, okay, so this is mine. And now what I'm looking for is, okay, so when is that square root of x actually bigger or equal to? And now, so going back in here, okay, well, the red one, which is the square root of x, is actually never bigger or equal to the line, right? So that's what we see there. It's that never happens, okay, within this particular case. So, okay, from here you might say, oh, well, I guess originally when we worked this out and we got this right here, hey, maybe that actually worked. You're correct. Sometimes it will work, but as you can see, it's problematic and you might second guess yourself at times, you know, when will it work and when will it not work? In this case, there is no value of x, and we can see that through the decimals graph right here. Okay, so if you ever have an opportunity to graph your left-hand side and right-hand side, do so to give yourself some intuition behind it, or at least sketch it in some way so that you can see it. And if you're going to be working things out, as we did in steps like here, okay, even as you work things out, okay, sometimes you have to be careful with nonlinear, as we did in this situation. So we have to think about that. So that was another example to show you, okay, with these nonlinear inequalities and kind of how you can tackle them. Here is another one, okay, that I have for you. So here is an interesting one. So let me copy this. And I'm going to paste it within here. And how would this one work? All right. So on the left, I have 1 over x. And if I think about 1 over x, so I know that 1 over x kind of looks something like this, right? So here, and then 2x plus 1, it's going to have a slope of 2 plus, and it's going to cross through 1 as my intercept. So it's going to look kind of something like this, you know, probably, you know, it's a line like that. So we know that these intersect here at these points right here, okay, in this way. So in terms of intuition, when I'm thinking about this, okay, what I would say is that, oh, okay, so I want to know, okay, when is it less than? Well, so it's going to be less than that 2x plus 1. So right here it's less than. And then it's also right here it's less than. Now let's not forget, because we have a problem here at 0, right? 1 over x at 0 is undefined. So there is no result for x, okay, in that case. So that inequality doesn't really hold. So here we have to kind of remove x is equal to 0, so it cannot be equal to 0. And then I have to find whatever this value of x is, because it works here, and of course it works all the way up to here. So it's going to have a bound. So x is going to be kind of bounded, okay, in this direction, excluding x is equal to 0. Now, I can try to find those points, okay, if I wanted to, in this case. But, okay, so what would I do in terms of finding them? In this case, I would have 1 over x, okay, so this is less than 2x plus 1. Now, this x from the denominator, so if I multiply both sides by x, okay, like this, I'm going to get 1. And then this is going to be 2x squared plus x. I can try to bring this one over. All right, so I'm going to get 2x squared plus x minus 1. And I can see, all right, does this quadratic, okay, basically have these zeros? So maybe I can try to find these 2 points that it might work for. Okay. Now, again, I mean, a quadratic, maybe it's possible for us to do. Now, we don't know if these signs right here are going to work, but visually what we just did for ourselves here, you know, this can guide us and we can see what these actually might mean. Okay, so let's take a look in decimals. So if I take this back into decimals, I'm going to bring it back here. And let me remove these. So I had 1 over x, so that's one of them. And then 2x plus 1, so notice that's the other one. And indeed, so what happened, okay, so it looks exactly as we had. And here are our intersecting points. So for these values, it works, right? And what we wanted 1 over x, and this was supposed to be less than 2x plus 1. And notice, this is exactly what happens. But it's not that easy, right? So here, so what we have is, so we have, okay, for x which is greater, okay, than this point, so x greater than 0.5, it works. And then it works also between, so on the negative side, between -1 and 0. So those are actually our answers. So here we have, it works for x, which is greater than 0.5, and then it works between -1 and 0. That's when this inequality actually holds. And now you can check, so if you would do this, the 2x squared plus x minus 1, you can find the zeros, okay, which would tell you this, but unfortunately it might not give you the inequality as we had it right here. So that's something for you to think about. And I wanted to show you these numerous examples where the nonlinearity, although it might be small, it can cause you quite a bit of headaches. All right. So here is kind of our last one, I guess, in terms of an example. So right here, I'm going to copy this, bring it down, and I would want you to think about it. Okay, how in the world would you be able to solve this? I mean, I have a square root. Okay, I have on the left-hand side, looks like I have a quadratic, and this is where those things come to use, because we can say that, oh, okay, well, this is just quadratic in its vertex form, right? So I know the vertex, I know that it opens upwards because it's positive, and then here, right here, this is just a root, but they're taking the negative side, okay, and it's being shifted by -1. So I kind of can figure this out more or less and then see, all right, when does this, okay, when is this bigger than, okay, this square root? All right, so that's what we would have. We would have a parabola opening up upwards, coming from here. It is being, okay, the vertex of it is at -1, -2. That's what we have there. And then from right here, so what we have is this is being shifted, okay, to the -1. So it's going to look something like that, okay? Of course, I'm just drawing it like this. So that means that for the from right here, like all of this does not make any sense because the radical isn't defined for values which are smaller than -1. Why? Because you can't take this the square root of a negative number. At least we won't get a real answer back. So really, we're just looking, okay, at anything past this line to the right. Okay, and when is one bigger than the other? Well, you can see that we're looking for the parabola when it's bigger, so it's going to be somewhere along here. Okay, let's graph it and then see how that works out if we were on the right track. And notice I didn't try to solve this because it would be a pain, okay, to try to solve this inequality whenever it's nonlinear like this. So what do we have? We have, so x plus 1 squared. This is -2, so that's our parabola that we talked about. And then we have negative, and it's going to be square root of x plus 1. And notice, so that's exactly what we had kind of sketched. This is what we have here. And it looks, okay, so notice that that's the point right there, so from 0. So it looks like our parabola is going to be bigger for values, okay, which are greater than 0, all right? Okay, and here, so if I go back, it's just greater or equal to. So if I put this entire thing in, so again, you can do that for yourself to see it. So it's greater or equal to, and it's minus square root of x plus 1. And notice that's exactly what it gives us, right? It's that at 0 and everything to the right. That's when that parabola is bigger. So that's what it actually means to solve these nonlinear inequalities. It surely is not as easy as it is with linear ones. Linear ones, the only thing you have to worry about is multiplying or dividing by a negative and then swapping things around. Here, boy, trying to solve something like this, an inequality like that, is it possible? Yes, of course it's possible, but it's going to be painful. And graphing tools help us a lot to visualize. All right, I'm going to leave it at that because the goal of this video was to show you, as kind of the student or someone who's kind of going through this, is that you shouldn't feel like, you know, oh boy, I don't know how to solve these nonlinear ones. Listen, I don't know how to solve them either most of the time because they're hard, right? So I do utilize graphing tools. So my goal was to give you some intuition. And instead of trying to solve right away, if you do have a graphing tool, always think back of functions. Take the left-hand side, take the right-hand side, and then see when one is bigger than the other or whatever the inequality asks you to do. All right, I hope this has given you some insight and some hints on how to tackle these nonlinear inequalities when you run into them. Okay, bye everybody.